In this video, I plan to go through two examples of hypothesis testing for the mean. So as we do these, we're going to be following essentially a four-step process. We're going to be setting up the null and alternative. We're going to be calculating a p-value on the calculator. We're going to be comparing that to a level of significance, also called alpha, making our decision, and then interpreting that decision. So let's take a look at this example. It says we have a sample of 40 pump purchases at a gas station, and the average amount pumped was 10.4 gallons. We have the population standard deviation, so remember that usually means we're going to be using some kind of Z procedure. So we have a population standard deviation of 1.2. I'm writing that down so I remember that. And we want to know, is there evidence the average purchase is more than 10 gallons? All right, somebody who doesn't know much about stats may look at this and say, well, you had a sample and it was 10.4, and you're asking me if we have evidence it's more than 10. Of course we do. 10.4 is more than 10. But what's weird about that thinking is that they're trying to compare a population to a sample and act like one sample proves something about the population without any math. What's really going on here is that you can use a sample to understand a population, but there's a probability associated with it, that p-value. So it may be that I have a sample with 10.4 gallons, which is more than 10, but it may be that's not enough information to say that in the whole population that's true, that we'll always end up with a mean bigger than 10. It could have been just this particular sample. We want to know the probability of that happening, which is the p-value. The p-value, again, is the probability of getting a sample like this, or more extreme if the null hypothesis is true. So looking at this, how can I write this as an H naught and HA? We want to know if there's evidence it's more than 10. So that'd be mu more than 10. So I'm going to write out the complement to that, mu less than or equal to 10. So my H naught and HA are mu more than 10 versus mu less than or equal to 10. Okay, so that's step one. Now I need to get some evidence together. I need to know, well, what's the likelihood of this kind of sample if I assume the mean is actually 10? And so that's the p-value. Since we have sigma known and we have a large sample size, I'm able to use a Z distribution, a Z test, a standard normal. And so what I do on the calculator is I go to stat and I go to tests, and this is actually number 1, Z test. So when you go into your screen for this, the first thing you're going to notice is you have a chance to pick stats or data. You're going to pick stats anytime you have the numbers already calculated for you. You're going to pick data if you need to put a list of numbers in first. Okay, so we're going to pick stats. Then notice it asks for sigma. See, this helps you remember with Z we need sigma, and so sigma, of course, is 1.2. Then it asks for x bar, that's the sample mean, we had 10.4. Asks for n, that's 40, the sample size. And then it has mu and mu naught equals, all this stuff. That's actually asking for HA. And so HA, notice, is a greater than. This is a right-tailed test. And so we want to highlight right-tailed test on there. And then finally, we get to calculate. And so the values that we get two important values. We get a p-value of 0.0175, and we get a test statistic of z equals 2.11. So if you were doing this with a rejection region, this would be the test statistic that you would get using the formula z equals x bar minus mu over sigma divided by the square root of n. So if you calculate this and try to do this problem using a test statistic in a critical region, this is the value you should get. This would be a really good way to test yourself. Now the thing is, when we're doing a p-value method, we don't actually need this information. Okay, so I'm leaving it there, but we don't actually need it. What we want is the p-value. So with the p-value method, what we do is we compare the p-value to alpha. If p-value is smaller than alpha, then we reject H naught. And it is. So p is less than alpha. It implies I reject H naught. So that's my decision. I reject H naught. It means that I have evidence leading me to believe that HA is true. So the way we would interpret this is we would say there is evidence that the average purchase is more than 10 gallons. And so remember, we're talking about the population of all purchases when we make this statement. We're not talking about these 40 anymore. Of course, with the 40, it was over 10. We're saying that that sample of 40 is enough evidence to say it's probably true for every other group of purchases you were to look at. Okay, so let's take a look at another example. Very, very similar. We're still talking about the mean. Okay, so in this example, we're told FICO scores range from 300 to 850. I think they may have just changed this range of values, but we'll keep it as it is for now, with a mean of 703.5. So this was actually a population mean. So the average FICO score, we know this is a population value, is 703.5. Okay, an analyst wondered whether individuals with high income had a different credit score than this. So usually if we have the population mean, we're not going to do a hypothesis test. There's no need to test anything about it. We know what it is. But we're not worried about this population mean. We're talking about the mean for high income individuals. Okay, now if we're looking at that mean, we don't know what that is, so that's why we're asking questions about it. Okay, we take a random sample. We found an average was 714.2, which is definitely different than 703.5, but then the standard deviation is pretty big, 83.2. So we want to conduct a test to determine if high income individuals have a different mean credit score. Okay, so what we're curious about is if it has a different mean credit score. Different is the same thing as not equal. So we're trying to figure out if the mean for high-income individuals is different from the mean for everybody else, which we know is 703.5. Okay, and then the complement to this would be the mean equals 703.5. So now I have my H naught and my HA. So I'm putting the one with the equal statement as H naught. Okay, so here's what I'm testing. Okay, now I got to decide where I'm going to p-value from. Do we satisfy the rules we need for a t-test or a z-test? We have a sample size that's good. But when I look at this sample standard deviation, this is from a sample. So that means that we don't have sigma. So this means we should be using t procedures. So if I was doing this by hand, I would now use a t-table and a t-test statistic. Since I'm doing this with a calculator, I'm going to use a t-test, which even if you do it by hand, it's still called a t-test, but it's straight out called a t-test on the calculator. So when I go into the calculator, I'm pressing stat, go to test just like before. I go to number 2 this time, t-test. And notice the information is very similar to what it asked me when I did a z-test. So I highlight stats because I already have the numbers calculated. And then mu naught comes from the hypotheses, so that's 703.5. And then this time it's asking for S. So S in this case is 83.2, sample standard deviation. And then we have our X bar 714.2. We have our N of 40. And then this is a two-tailed test. A not equal is a two-tailed test. Okay, and so that's what that last line is asking me for. So I go to calculate, and I get a p-value of 0.4209. Now that other value on the calculator, the t-test statistic, that's exactly what you would get if you found the test statistic by hand. Okay, so I'm supposed to compare p to alpha. P is larger than alpha, which is 0.05. So that means automatically that I failed to reject H naught. Okay, if I fail to reject H naught, that means I don't have any evidence towards HA. Notice I did not say H naught is true. There's no way to know that unless I look at all high-income individuals. All I can say is, I didn't have anything to prove it wasn't 703.5. So one way I could say this is say there's no evidence that the mean for high-income individuals or people is different than the mean for everybody else. We have no evidence to support that at all. So we don't know, maybe you could have a hypothesis about something else and maybe that could be proven, but we don't have evidence to prove this hypothesis. So that would be my interpretation. This procedure is going to stay the same no matter what we're doing a hypothesis test about. We're going to find the null and alternative, we're going to find the p-value, make our decision, interpret that. The other method, again, is where you, at the stage after you have H naught and HA, you draw a rejection region, and then where your test statistic falls determines if you reject or not, and then you interpret that. P-value method can be used anywhere where you can calculate a p-value. It depends on the type of test. On the calculator, we can do almost all the tests and get a p-value.